the essence very, very quickly. Let me turn this off. Okay. All right. I've sent you a bunch of emails with what the required reading is for this material. And I know what you're thinking. This guy is crazy. He's telling us to read too many things. I am crazy. I want you. This thing smells very good, Ria.
Thank you.
You are trying to distract me. You're working hard, and you know, I want it to stay that way, because at the end you will be truly rewarded. Yes.
So the fitting linear models PDF, is there like a section of that that you want to read, or like?
I put the whole manual there so you can go and find out anything you need. And so if we are doing multiple linear regression, you go and you read whatever that is. I don't want to say I read page this from that to that.
Okay.
I am treating you as advanced students, okay? So if we are doing, so just go and look up multiple linear regression, because it drives me crazy. The editions of the books change and the pages change. So read up on multiple linear regression. And in any test, I will not ask you, you know, very esoteric things, very deep things about anything. But having those manuals there allows you the freedom to go and prepare yourself for after the class is over. That's the whole idea. Okay, so this is where we are. And you have a little bit of reading from here. So I told you what the reading is. Let me not repeat it. I'm going to start with this document. Again, ignore anything that references Excel minor. I spent an extreme amount of time to try to prepare for the class because of the new software, and I'm changing, I'm adding new documents, and so these are all JMP specific. I changed this color. So, but let me tell you, today I will talk about a number of business rule related concepts, but let me tell you what KNN. KNN stands for K nearest neighbor. The K is a number, it could be 1, 2, 3, 4, 5. Okay, here is the way to understand it. And I ask you to play a couple of small videos to understand the concepts. Some of you are seniors, some are juniors, some are sophomores. Okay, I don't know who is sitting where. Let's say that if a new student walks into the classroom, I want to to classify that new student as one of those, junior, senior, sophomore, blah, blah, all right? So let's say I will set K equal to 1. So this is how I'm going to use that K equal to 1. A student walks into the class and sits right next to you, okay? And because you're the nearest person, so then we will classify the new student to be, what are you, junior, senior?
Sophomore.
You're a sophomore. We will classify the new student to be sophomore because you are the one person closest to, right? So this is one NN, one nearest name, okay? A student comes in and he sits right there. And I'm going to use K equal to 2. So now, this student, I'm looking for the two people closest to him, right? We have Kyoka, and Matt. Okay. You're a sophomore, you are?
Junior.
A junior. So at this, for this instance, right, there's a tie. So you say, which one? ties many times are broken randomly. Other times ties are broken based on some sophisticated rule, right? Okay. Don't tell me what you are. So that was with k equal to 2. That means a new person arrives into the class. Somebody come in? Oh, sit over there. So you're either a sophomore or a junior.
Sophomore.
Oh, my God. Some sunflower seeds. Okay. Now, a new student comes in, but you ruined my next thing. I was going to involve her. That's okay. We'll do this. A new student comes in, and since you sit over there, and the new student sits over here. Now I'm going to use k equal to 3, right? So I'm going to look at the nearest 3 people to where he or she sat, right? So we have 2 sophomores. These are very good. You have to break it. No, not like this, with your teeth. See, you have to explain it. You know, they don't know, these poor souls. No. This is actually, you go like this, and beat inside. These are roasted. You are more advanced than I am. Back teeth. That is sneaky. She's done a lot of analytics work. Beat inside. These are fantastic. In fact, I am the best customer of these days. I buy like 5-6 bags, and when in my family, when we toast, we don't talk for hours. And when I have those things, it takes me 3 times longer to prepare for your lectures. Very good dog. Yeah, see. Okay, so the new person sits here. So K is 3. You look at the nearest 3 people, and we have 2 sophomores and 1 junior. The person will be assigned to the majority. Will be classified. Okay? So K equal to 3. A new person comes in, sits right here, and then K is equal to 4, so then we look at the 4 nearest people, right? And we have 2 sophomores, 1 junior, and senior. The majority is sophomore. The person who will still be classified as sophomore. So you can have ties. To minimize ties, we make K into an odd number. Okay? That's the idea of KNN. It has its advantages and disadvantages. It has usages in certain places. You see, there's no algorithm that will apply to all scenarios, but for different scenarios, you have different algorithms. Okay, so let's open this document. These are the PowerPoint slides from the new version of the book. Okay, so you have one reading, another reading right here. The plus sign means these are documents that you're responsible for. So let me open this. They cleaned up the computer once again, and they told me via an email that they installed version 15 of JMP. It's not here. Okay, anyways, all right. So, okay. What I'm going to start with today is by doing, I'm not going to be doing KNN, but I am going to show you how many times you do not have to automate things too much. You don't even, sometimes you may not even need to use software to create a new business rule. Algorithms are business rules, okay? So this is from the Evans book, and you have this data file. In this class, I want to prepare you not to zoom in. I want to prepare you to think about the concepts, not to look at JMP. JMP is just a tool. Any software you use, look at them as a tool to help you accomplish something. When you build a house, you don't worry at the end. I mean, you need to think about the house you're trying to build, and you do not need to worry about, well, you do, but using a hammer to put nails on the wall is just one of the tools that you use to accomplish your goal. Think small and big at the same time. All right, so here is a data file. It's called credit approval decisions, credit approval. And I have this file here. This should all be this color for some reason, the color. So you see how I want to show you how you can take an Excel file and paste it into JMP, okay? Because it's a good way. So I have this credit approval Excel file. Here. Now, in order to use KNN with this later on, we need to have everything numeric. But let's say I want to take this and put it into JMP. Okay? So let me also open, well, let's see, JMP. Oh, they have all of them, 13, 14, and 15. So when I open something from here, which one is it going to open? Probably 15, but let's see. How do we find out? We go to help, about, JMP. Oh, this is 13. Okay, that's fine. That's the one it opened by default. And Erica, did you take care of that problem?
Yeah.
So let me actually go analyze, predictive, make validation, see how it's here. What happened?
I just went to the library computer and it worked.
Okay, but the issue I sent you an email, you have JMP on Mac,
Yeah.
and when you click analyze predictive, you didn't get these options. You didn't get the make validation column. Do other people have that problem? Okay. So when you're okay?
Yeah.
It's the enthusiasm of the material. Okay. So let me to create a new. So I want to copy this data. Okay. So let's do this. I want to display both at the same time. Okay. So I click File, New Table. All right. So I select all of these. Control C. When I go into this, okay, you do not want to do paste. You want to do edit, paste with column names. If I do paste, all right, if I do paste, it will make the headers, it will make them data. But you want homeowner to show as the column header. So what you want to do is you want to say edit, paste with column names, and then you have the headers from Excel becoming the column names. Okay, so this is very nice. And then you see how here, from the data, it identifies this as, if you double click on homeowner, it's a character nominal. Okay, it's character data. And because anything that's numeric, it classifies it, it makes it into numeric continuous best. Now, we want to turn this into ones and zeros, the same with this. Approval will be 1, the decision and reject will be 0. You can do that via the, so you have this, right, very easy. Columns, utilities, you select the column that you want to dummify, right? And then you do columns, utilities, indicator column, and if you say append, so you see this becomes homeowner, no, homeowner, yes. You want to, because you have 2 values, you want to eliminate this. So this is a little bit of a quick review, right? So anyways, I have it, this credit approval original, all right? This is how it is. This is the original without these columns being dummified. And then I have credit approval coded. Coded means it's the version that that is the original pre-processed, having things the way that they should be. Okay. So what I want to do, I'm looking at this and I'm looking at this right here. This is coded, okay? Coded meaning I replaced the yes, no with 1, 0, the approval, reject with 1, 0. So one way or another, you do that, okay? And what we want to do next is to just do a scatter plot. I'm not doing KNN now, okay? I'm not doing KNN. So, I said generated with Excel Miner. I'm going to do this with jump. So here is this, and I want to minimize how many of these windows I have open. All right. Control Shift plus zooms in. So to do the scatter plot, there are many ways. You can do graph. The graph builder, okay? Open up the graph builder. I want to put credit score on the x-axis, years of credit history on the y-axis. Whenever you see this line, see if you click the scatter plot with the line, it just gets rid of it. But I have the column that I want to predict is the decision. You have people that apply for credit card for a credit card, and what is this? Somebody? Okay. Here is my data, okay, and the bank is to make a decision, or the credit card company, to accept or reject. All right. So now I made the decision. If I go to decision, if I double click, right now it's numeric ordinal, and you will see at some point I will change it to numeric nominal, because that does make a difference in KNN, but for right now we don't care. All right. But when it's green, it's numeric nominal. If I change this to numeric nominal apply, then it becomes this red brownish color. Okay, let's leave it back to the way it was. Jump does different things based on the data type. This is important to know. Okay, so I want to do the scatter plot. And I want to color things based on the decision, ones and zeros. So you can take decision and move it into color. And then you see you have two different colors. 0 is blue, all right, and 1 is this red. Let me right click on that, and I want to change the size. Or maybe, let me make the blue into this shape to make it easier to see. And this one, you right click, and you make this into this shape. It's a little bit easier to see. Is this two-dimensional or three-dimensional? Three-dimensional. You have the credit score, the years of credit history, and then you have the decision. Three things. So you have a three-dimensional graph on a two-dimensional surface. There's a way to make this bigger and without dropping something into here. But anyways, so let me, okay, big. If I do Control-Shift+, it makes it a little bigger. So these are not, the pluses are not that visible. I double-clicked. I want to make it bigger and maybe change the color. Let's see. Okay, so if I click on the plus, or if I click on this triangle, okay, it highlights. You have these two. Now, this 0 means the decision is to reject. These people were accepted for the loan. So what you can do, you have a lot going on here. If you see when I move over this horizontal x-axis, if I double click, at about here, if I draw this vertical line, okay, this reference line, at about 640, so I will say 640, I want to add that here, click on it, and I want to change the width of this and make the color red, or whatever this color is, red. You see this line right here? This is at about 640. And the way I get this line is I double click on the x-axis and I create it right here. 640, 1, 2, 3, update 4. So it becomes thicker. So I can very easily create a rule that says if the credit score is less than or equal to 640, your application will be rejected. And if it is greater than 640, it will be accepted. But you also see here, there are two guys right here that their score was 760 or something, and it was rejected. Having this, okay, having this business rule, it allows you to generate a classification table. That should be here. This is another rule. Here. You should be able to do that very easily. I'm not going to go over it. You should be able to do it. Okay? So this is the business rule. If credit score is less than or equal to, reject, otherwise accept. And then you do the classification or confusion matrix, and you you can evaluate accuracy, error, and so forth. Now, looking at this picture, let me I double click here, and I want to take this line off, okay? And let me do a print screen and go to Paint. Sometimes you need to exit the most sophisticated tools, and I'll show you what I want to do here in Paint. And you look at it and you say, what about if I draw a line this way? And you can move this up or down, okay? And make it a little bit thicker. and then, see, you can find the equation of this line very easily, because all you need to do is identify 2 points, one here, maybe I wanted the line to touch another one of these points. Oops. All right, right here. So I want to identify 2 points. All I need is actually I did have, this is one, and here's another. And once you have 2 points, then you can draw the equation of the line that goes through these points. You can find this equation. All right? And this will be something like, oops. It can be something like y equals something, the slope times x, okay, plus b. And it turns out that this equation, I'm not going to test you on that, is right here, okay? Years equal every time they re-image this, I have to. There you go. So the equation is years, that's y, right? That's y, equals, the slope is negative 0.095, all right? So y equals negative 0.095 times x, x is the credit score, this is y, plus 74. Where are you? Okay, plus the 74.66. Now, if you move everything to the left, you can rewrite this as y plus 0.095 x equals to 74.66, all right? And every point here, for every point here, this equation right here, let's call this equation, okay, EQ. EQ is less than or equal to 74.66, and every point here, this equation will be greater than, okay? And again, you can create the classification table. And I want you to create those yourself, generate those yourself, all right? We talked a lot about training and validation data, and so we know that the training data, and I have a nice picture here, okay, the training data is used to generate a model that has statistical properties. When we worked with multiple linear regression, okay, when we work with multiple linear regression, a model was generated from the training data. Initially, right? Initially, what you have a file, all right, a whole file. We want to take a certain percent of that for training, a certain percent of that for validation, and we can have a certain percent for test. The training data is used to generate a model. Okay? Now, this was repeated many times. You know this. You may be asking yourself, why does he keep repeating it? I do not do anything without a purpose. These models, the statistical models, these are called eager learners. Okay? Eager learners. And last time I told you, so you see how I define a new concept, right? I loaded one video. It takes an extreme amount of time because the videos, the recordings are saved somewhere, then I have to download them, and then I have to put them in YouTube. So I've added a new one. An eager learner is a learner who takes the training data and learns and produces a model. The reason I mention that now is because, I'll mention this again, KNN is a lazy learner. Okay? See, with the KNN algorithm, the training data does not generate a model. The computer takes the training data. The training data, when I was talking the example with freshman, sophomore, and so forth, is the algorithm looks at everybody in the classroom. There's no model that's generated. The model is used only when a new person comes in. So, okay, and the training data is used when K is 2 to the person sits somewhere and looks at the nearest two people. So that there's no model that's generated. So KNN, that's why it's called a lazy learner. So I talked about eager learner, lazy learner. Here is what, and I want you to become true scientists, right? True scientists. A true scientist has curiosity. You go and you say, let me read up more on lazy learner and eager learner. That is what I call parallel learning. Okay? So, but basically I explained it, but if you read up on your own and you go, I know you have other classes, and you go and you do a couple of maybe other examples and so forth, or you read up more, you may find it interesting and do some research there. Okay, anyways, so the validation data is used to evaluate the model, or in the KNN's situation, the validation data, you have the training data, then you go to the validation data, you take the students that are in the validation data, a new person comes in and sits somewhere there, and you use them. So the validation data validates, and the test data, if you have it, revalidates. The true application or appreciation of the model is when you have new data. So you take the whatever process you use to evaluate a new student, and you go to another class, and you say, okay, everybody sits down, and a new person comes in, k equals to 2, you look at the nearest two people, you see if there's a majority. With 2, you may or may not have a majority, right? There's a tie. You look at k equal to 3, you look at k equal to 4, you look at k equal to 5. With each one of these k's, you can create a classification matrix, right? There's a reason I'm saying what I'm saying. Okay, you will see that. All right. So this is the idea. This is what's going on when you're trying to create a model. Generally speaking, when you're doing data mining, you have various strategies. This here was from some book. I will call this unsupervised learning. Okay, unsupervised learning. So you have different strategies: supervised learning, unsupervised learning. The supervised learning, you have classification, prediction. They're both estimation. So last time, multiple linear regression is here. All right, this is a supervised learning prediction. KNN is classification. So this is where you are assigning somebody to, you have a 0-1 situation, or 0-1-2, freshman, sophomore, junior. Ideally, they're both really a prediction, but when you predict somebody to be in one of a small number of classes, that prediction is called classification. And this market basket analysis is really under here. So here we will be doing clustering. This is an unsupervised learning. Market basket analysis is here. We will see that. And there are others. And under supervised learning, you have others. Okay. Now this is all with structured data. So above this picture, you have data. Okay. And you do, and you have structured data. Okay, you have columns like last name, first name, and you have this path, and then you have, oops, so this is one, and then you have unstructured data, videos, audios, and so forth. This is where big data comes in. I mean, you don't have to do it in big data, but when you have audio, video, the volume becomes just huge. Okay? So we are not playing too much with this, but I want you to be aware. So you have two types of data: structured data. This is the traditional data. Okay, get involved with the AI Institute of Northeastern. Even if you are a senior, have contacts within the school. Why? Larry Ellison, the multi-billionaire, one of the richest people on earth, was working for IBM. He left, he kept contacts within IBM, and he read via these contacts the first person on relational theory that was written by his friends within IBM, and he, together with Allen, a couple of other guys, they got a $50,000 project for the Department of Defense. That was the beginning of Oracle. He buys his own islands. Okay, so I'm trying to also motivate you and challenge you to go big. We talked about partitioning with the validation data, right? So this is ignore. This is Excel minor. This is that data set. Here is here is what is this? Let's say you have this new data, and okay, so this is my new data, all right, and this new data does not have a, let's say, a decision. This is rule 2 right here. This is rule 2. I don't have rule 1, but so what was rule 2? Here is years, and this is the credit score. This is X, and this is Y, right? So here you calculate years plus 0.095 times credit, and you compare if this is less than or equal to 74.66. By the way, I offered something to you on Thursday. The homework from chapter 6, I gave it to you. I want you to study and find out what's going on. If you find a classroom somewhere, then I can sit down and spend a couple of hours to go over that homework for you. I send you an email, right? Because read it, try to do as much as possible. And listen, if you are behind the homework and you are a day or two behind, I don't care about that. What I care about is that you learn. You understand? I know that I'm being hard on you, but at the same time, I want you, the main things I want you to learn. Of course, you want to get a good grade, and I respect that very much. That's what I want to do too. But the bottom line is this. At this point, if you are a day behind or a couple of days, these are not issues with me. The issue is if you're working hard or not. You understand? I don't want to treat you like high school students or freshmen or anything like that. I treat you as an adult, and I expect that you will respond and work hard, right? Okay. So I offer that. Get a room somewhere in the library. I'll go and I'll sit down and I'll go into detail, all right? All right, so you do that comparison, and if this is if this is true, then this is if it's less than or equal to, right? This is the equation of the line. It's like that, and you have points. Here, you reject, okay, if you have a less than or equal to, and here you accept. And accept is a 1, reject is a 0. So you see here, this is right here, you will put a 1. Oh, the other ones are zeros. All right? That is one rule. And you can create a classification matrix. I will tell you why I'm saying this with this rule. So here is the actual 1 and 0, actual 1 and predicted. Predicted is at the top, right? And this is the actual. So you generate this classification matrix, and then you generate your accuracy, all the statistics. Error, 1, 0, 0, 0, and so forth. You can also use Rule 1. What was Rule 1? Rule 1, so this was a classification, the classification with Rule 2. Rule 1 is, if you look at this, Rule 1 is if this is compared against 640, right? If the credit score, if X, is less than or equal to 640, then the decision is 0, otherwise the decision is 1. So if I use that rule, right, I'm going to have 1, 1, 0, 0, 0, 0, 1. So you have a 1 and 1 here, and everything here is 0. You create a classification matrix for this, right? And you can compare the accuracy and the error with this, and with the accuracy and the error from that. And the one that gives you the greatest accuracy, you say, well, I'll go with that. All right. The more I use jump, and I'm not an expert in jump by any means, but the more I appreciate it, I would have said the same thing with any tool. I don't care what the tool is. There are many great tools. All right. So, all right. KNN is a classification. The essence of the algorithm is, in fact, let's play that video that I asked you to play, because these are the videos. My friend courting.
N means k nearest neighbors. It's a very simple algorithm, and given n training vectors, suppose we have all these A and O letters as training vectors in this b-dimensional feature space, the KNN algorithm identifies the k nearest neighbors of C. C is another feature vector that we want to
So these are the students, A's and O's. This is a new student arriving, right? Is this going to be classified as an A or as an O?
to estimate its class. But in this case, it identifies the nearest neighbors regardless of labels. So suppose this example. We have k equal to 3, and we have the classes A and O. And the aim of the algorithm is to find a class for C. If k is equal to 3, we have to find the 3 nearest neighbors of C. So we can see that in this case, the 3 nearest neighbors of C are these 3 elements here.
By the way, distance is being used with KNN, and it is the Euclidean distance that is used. We'll talk about distance. I asked in another class, for example, I asked somebody here, who is the person, Kyoka, who is the person farthest from you? And did I ask you before? I asked somebody here, and you looked over there and you said, that guy, right? Distance is one of many similarity measures. So you truly have similarity measures, and then you have, and then I told you that the person farthest away from you is yourself. when we say distance, automatically we think of the Euclidean distance. If you take a tape and you measure the distance, that's the Euclidean distance. There are other types of distances. There's a statistical distance. So if you like classical music, and my friend, what is your name over there?
Dave?
Dave. And Dave likes classical music, then you are close, statistically speaking, because you have the same interest. But if you ask Jason, what music do you like? Do you like classical?
Yeah, sure.
You should say, I hate classical.
I love classical.
This guy is tough. But let's say that he hates classical, right? Then you are far away from Jason in terms of that similarity. So distance is a similarity measure, okay, because you can be far away and enjoy the same type of music. So you have a friend in Hawaii, let's say, and she likes exactly the same song, exactly the same singer, blah, blah, blah. Then you are very close with that person. Here, they use Euclidean distance, the tape measure, right?
We have one nearest neighbor of the class A, and we have two elements of the class O, which are near to C. So we have 2 votes for O and 1 vote for A. In this case, the class of the element C is going to be O. This is very simple how the algorithm K nearest neighbor works. Now, this is a special case of KNN algorithm, is that when K equals
Don't worry
1,
about the notation, pay
we
attention
must
to the concept.
try to find the nearest neighbor of the element will define the class. And to represent this in a feature space, each training vector will define a region in this feature space here. And a property that we have is that each region is defined by this equation. We have a distance between each element x, and xi has to be smaller than the same distance for each other element. In this case, we will define a Voronoi partition.
Okay, he mentioned a Voronoi partition. I'm not going to ask you to create it or write a program, but I want you to know the definition. This is what I call extra reading. When you've seen a concept, have a curiosity.
Of this space, which can be defined, for example, this element C and this element E, B, and A will define these regions, very specific regions. This is a property of the KNN algorithm when K is...
Somebody comes up with a template and they put it on top of the data and they say this is a Voronoi partition, which basically means if you are anywhere in this area, right, you will be classified as a C. C is closer. If you are on the borderline, or like in this space, in this dot right here, the ties will be broken, either randomly or somehow. Ties will be broken, right? And different people choose to do it differently. If you are anywhere here, if this is a freshman and you sit right there, you're classified as a freshman. If you sit here, you're classified as a sophomore. If you sit here, you're classified as a junior. So this is called the Voronoi partition. Somehow it's determined. We don't care how, but that's what a Voronoi partition is.
Equal to 1. We define regions 1, 2, 3, and 4 based on the nearest neighbor rule. Each element that is inside this area will be classified as A. As well, each element inside this area will be classified as C. And the same for the region 2 and region 3 for class C and D as well. Now I have just some remarks about the KNN. We have to choose an odd value of K if you have a 2-class problem. This happens because when we have two classes, and if we set k equal to 2, for example, we can have a tie. What will be the class, the majority class inside the nearest neighbor? So we have always to set odd values for a two-class problem. And also the value of k must not be a multiple of the number of classes. It's also to avoid ties. And we have to remember that the main drawback of this algorithm is the complexity in searching the nearest neighbors for each sample. The complexity is a problem because we have lots of elements. In the case of a big data set, we will have lots of elements, and we will have to search the distance between each element to the element that we want to classify. So for a large data set, this can be a problem. Anyhow, this KNN algorithm produces good results. So this is the reference I have used to prepare this presentation.
Here, you see he mentions a book that, I see two Greek guys over here, that he uses as a reference. I'm not asking you to go and read it, but as you are taking the class, jot down these references for later on. If you go to work somewhere, you have a place to go and a reference. That is how you plan for things down the pike. Okay, I'm not going to play the other video. You can play it yourselves. Okay, in this other videos here. This is Professor Sadawi, a PhD in computer science, and he works within a hospital in somewhere in Canada. And so I ask you to play that. But this was a short video, 4 minutes, and it shows you the how simple KNN is. It's really very simple. Okay. So, and this is that video. Basically, this is what it's talking about. The key thing is, how do you pick k? Because one of those k, so you pick k equal to 1, you come up with a classification matrix. K equal to 2, k equal to 3, k equal to 4, and so forth. What is the best k? The best k is the one that when you look at the validation data, you have training, validation data, test data, you look at the training validation data, and you come up with, when k equals to 1, with k equals to the classification matrices, and you pick the one that has the smallest error. Now, when you do KNN, I mentioned, let's see, this is all Excel minor, so you can ignore it. This is just a repetition of the ROC. Okay, this is output. Okay, output of the Excel minor. So here's where basically I used new data and I applied the KNN algorithm, not the K, I applied rules 1 and 2, okay, to decide the predicted class, all right. I mentioned another project here called Orange. I don't think we'll have the time to do it, but this is a very nice website. I think I mentioned that before. Saeed Sayad. Okay, very nice. And so you see we are doing predicting the future, modeling. So you see under regression, similarity functions, don't worry that he puts it under regression. Here's k nearest neighbor, right? And this is a very nice website because it talks about KNN, and then at the end he has exercises and also an exercise in R, okay? But he has an exercise using Orange, and he updated his website, oops, because there was another exercise here. There was another link that said interactive. But what I want to get from here, okay, we talked about the Euclidean distance. We know how to find the the distance between two points. And I want to talk about the Manhattan distance and the Hamming distance a little bit. Let's see. All right. Leave that over here. If I have a record that has these coordinates, I'm just making up numbers. 1, 2, 3, 4, 5, 6, 7. So this is in 7-dimensional space. Make this guy bigger. Okay. So this is point A. And I have another point 9, 8, 7, 5, whatever. 1, 2, 3, 4, 5, 1, 2, 7. So 1, 2, 3, 4, 5. And you have point B. What is the Euclidean distance between those 2 points? All right. So if you remember, right, the Euclidean distance is 1 minus 9 square. You take the corresponding points, plus 2 minus 8 square, plus 3 minus 7 square. The Euclidean distance is a number, 10, right? Regardless of the dimension, right? Plus dot 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 plus 7 minus 7, okay, plus 7 minus 7 squared. Okay, that is whatever, that is the Euclidean distance, right? Call it D1, right? And that's the formula right here. You see, this is x1, x2, and so forth. This is y1, y2, right? And that's exactly what this is, right? So it doesn't matter. I mean, this will be a number like, I don't know, 20 or 13, right? What is the Manhattan distance? In New York, if you, so these are streets, and the streets are kind of perpendicular, vertical to each other. Okay, so let's say you are here and you want to go here, right? And let's say this is the point, so this is 2, this is 2, 1, 2, 3, 4, 5, 6, this is 6, 1, 2, 3, 4, oh, this is a coincidence. So this point right here is the point 6, 6, all right? And this is the point 2, 2. So this is A. You want to go from point A to point B. In New York, you cannot, the taxi cannot go this way. That would be the Euclidean distance, right? But it's called Manhattan because in Manhattan, the taxi needs to go this from, so this is A, and this is C. From A to C, and then from C to B. So the Manhattan distance is this distance right here. You see this xi minus yi. So this is x1, y1. I'm sorry. Well, even though it's the way that they use this notation is like this is x1, x2, and this is y1, y2, even though, so I'm not using the Cartesian product, the Cartesian plane properly. But this distance here, from A to B, the Manhattan distance is this guy right here, which is, so 2, 2 is right here, right? 6, 6 is right here. Right. So from here to here is what? 1, 2, 3, 4. So when you take, to find the distance, this would be x1 minus y1 plus x2 minus y2, the absolute value. So this is x1 minus y1 is 2 minus 6. That should, I don't, okay. All right. So this is x1, x2. This would be 2 minus 6 plus 2 minus 6. This 2 is the first 2, and this 2 is the second. So this is 4 plus 4 plus 4 or 8. So you have 4 here, 1, 2, 3, 4, and then 1, 2, 3, 4. So that's the Manhattan distance. The Manhattan distance, you cannot go this way because there are buildings. There was a student who did not like that definition. He goes, that is not the distance. Because, okay, this is the Euclidean distance, but the taxi cannot cut through the buildings. Right? So that's the Manhattan distance. The Euclidean distance is this, and this is theoretical distance, right, but cannot be traveled. Manhattan distance is the reality, right? The taxi cannot go this way. The taxi has to go A to C plus C to B, and they charge you, let's say it's 8 miles, whatever, and they charge you for 8 miles. Okay. Now, some of you will go and work in certain, let's say for the government, and there you have the Hamming distance when the data is binary. So if you where was this one? This one. Okay. If you have espionage, some people are very good in breaking codes. You get a signal that has 0, 1, 0, 0, 0, 1, 1, 1. I'm making this up. Okay, this is what you get. Okay, and this is the baseline. All right, this is the baseline. And let's say that you get the baseline is all ones. And I will tell you a real story, what happened. How the Department of Defense, the United States Department of Defense, there was a warning that there were 30 seconds, and there were 4 missiles. The United States, this goes back about 30 years. The United States, in order to prevent the enemy from destroying cities, there were 4 missiles that the U.S. was sent to eliminate Boston, LA, New York, Chicago, 4 cities. This is a true story. You guys never heard of this, okay? So there's a warning, 30 seconds for this thing to go on. What happened was this, they had a computer, and the computer was where mine is, and there was a cable from here to the plug. And there was a counter with 8 of these. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 9. So there was an internal counter. There were 8 switches. They were all set up to 1. In order for this to happen, somebody had to flip 8 switches, which is right. I mean, it's a lot of work. It cannot happen by accident. But what they didn't realize, anytime somebody was walking and stepping on the cable, it had a possibility of changing the switch. It was a matter of time. After a few hundred people walked and stepped on the cable, all of these switches became once, boop, 30 seconds to detonate. So, of course, they stopped it. This is a reality. Now, so homing distance, a lot of times you have this, right? And like in this case, and you measure the distance. So here is x1. This is x2. 3, 4, 5, 6, 7, 8. x9. I want your mind to get used to that distance is not just what we think of distance. So here, and this is y1 all the way to y9. Okay. If these two are different, the distance is 0. If these two are equal, the distance is 1. So here's the distance. All right? So the homing distance, this formula right here, is x1 minus y1 plus x2 minus y2, the absolute value, right, plus dot. So if these two are equal, either zeros or ones, right, this will be 0. So you have 0 minus 1, this one right here, right? The next one is 1 minus 1, that gives you a 0. So anytime, okay, so this here is the distance is 1, because they are different, right? If they are different, the distance is 1. If they're the same, the distance is 0. So the distance here will be 0, right? So the distance here will be 1, 2, 3. Let's say I had a 0 here, 4. You see, if I have 0, 1, 0, 0, like that, let's say, so this is all ones. Actually, all right, let's leave it the way it is. The baseline is 1. But if you had a 0 and a 0, right, the distance is 0. It's only when they're different. So how many different things do we have? 1. So let's put a plus there. 1, 2, 3, 4, 5, sorry. So the distance is 5, the Hamming distance, right? So the Euclidean distance is a particular case of Minkowski. I'm not going to talk about Minkowski, but oops, there's another distance that I want to, where are we? Whoa, whoa, whoa. Okay. There's another distance that I want to bring up that we will talk another time. Let's see, Mahalanobis distance. This is statistical distance. This is a statistical distance. So this uses correlation, covariance, things like that. I want to show you, so Mahalanobis is a famous scientist from India, and this is used heavily in analytics, data mining. I want to help you out with this, or to try to go over the Mahalanobis at another time. Now, in this example, he actually has an interactive, this interactive. I'm surprised that he took it off. I was able to do this at home 2 days ago. Sayat, a KNN interactive example. Here, this, oh, there it is. All right, you see this right here. Okay. This is KNN. Do I need to click something here? I read somewhere that they will do away with the flash player. Is that, anybody read that? Yeah. What are they going to replace it with?
They're trying to replace with like Java.
Okay.
You have to click the top right.
Up here, yeah. I don't want it to be blocked. Where do I'm not good with Chrome. There's somewhere where I can, did it unblock it? No. Done? No. How do I unblock it? If I press Control and this, yep, there should be. Ah, boy. Okay. somewhere here there is a, I don't want to spend too much time with this. No. Anyways, here is the idea. You have a you have this data, age and loan, and you. No, this doesn't do it justice. You need to see the. Visit the block site extension on the Chrome Web Store. Block site. Should be here. Okay, I was going to show you, if you have this data, I mean, this can be age, it's what we were discussing. Here's the data. You have age on the x-axis, you have loan on the y-axis. The red means that the person defaulted. The blue means that the person did not default on the loan. Defaulting on a loan means you are not able to pay the loan. So if you have a new customer in the bank, a person that made the loan, and the person is 40, something like this guy, let's say it's 46, something like that, years old, and the loan is for about 140, you want to try to predict, you want to be able to classify the person as defaulting or not defaulting. Using KNN, you look, if K is 3, you look at the 3 nearest and you look at the majority. Oops, you say we have a tie. Well, what happens in that case? You got to break the tie somehow. So that's, there's a very nice interactive tool that you can anyways. Now let me do something today quickly. I'll do the KNN algorithm with this credit approval coded data. Okay, So let me open this up. So when you're trying to, and we'll of course start with that next time. So here's my data, all right? You want to clean up, you want to prepare, you want to do pre-processing with the data, all right? So this is actual decision. Anytime the data is supervised, why is the data supervised? Why are we doing supervised learning? Because we know we want to classify the person as one of these. All right? One means the loan is approved. So this is data that the bank has. The bank looks, if you are a homeowner, what is your credit score, years of credit history, revolving balance. Revolving balance, I think, is, you know, when you have a credit card and they say that you have a limit up to, that you can borrow up to 8,000, and this is, and you're using 25% of that. Advice as a friend: learn your credit score and educate yourselves about your credit history and how you can build it up. It has and it will have a major effect in your lives, a lot more than you think. Find out, learn it. In one of my classes, this young lady found out when I asked them to look into the credit history, her aunt used her Social Security to make a loan. And the young lady had no idea. And she looked up and found out there was a loan against her and her credit was going to be affected for a long time. Okay. So whenever you have supervised learning, the first thing you want to do is partition the data. And to partition the data, one of the ways, the best way probably, is to do analyze, predictive, make validation column. And here is where you can specify. Now we don't have a big data set here. So 0.75, 0.25. Today I'm just going to make this 0.60, 0.30, and 0.10. Right? I don't like now that I use the word validation for this. By the way, you see how I use these percentages, 0.6, 0.3, 0.1. When you are inside jump and you are, let's get out of here, and you are here, right here, the home screen, you can click File, Preferences, and you can set many things up so you don't have to repeat them. Platforms, we are doing K, nearest neighbors. So all these things are called platforms. You see the validation portion? You can decide to make that 0.6. You can decide that the K, you'll see, I'll tell you what that is a 5. And you can decide what kind of report summary. So you can set things up so you don't have to enter them. There's millions of things that you can do here. You can set up print settings, blah, blah, blah. Okay, let me not do it, but I want you to know it's there. So, all right. So I do analyze, predictive, make validation, and I made this 0.6, 0.3, 0.1. I'm going to call this partition. And on purpose, I'm going to call it partition Demetrius so that you know you've created it. Now, there are two types of ways to generate the partition. One is click formula random. This is what I've been doing so far. The other one is this fixed random. If I want, see, I'm going to enter a number here. It could be any number, 1, 2, 3, 4. This, if I click fixed random, will generate training, validation, and test, right? The seed that see this column with no formula seed? If I do this tomorrow and I wanted to generate the same partition tomorrow that I did today, I can enter that seed, 1, 2, 3, 4. That's what the seed does. You understand? Because many times, especially in the healthcare, you do an experiment, right? And that's why they take a lot of time to sit down and write all the parameters. The temperature in the room was this, I had this much of this chemical, that much of that other chemical. So the seed is a number that you can use to recreate the same allocation of data. Okay? So that's what the seed does. All right. Now, if you want to see all of the training data and validation together, you can right-click here and click sort, let's say ascending, and you see now you see all the training data, the validation, the test, and you can, if you want to, save them in different files, right? But you don't have to to do this. So if I press Control Z, it undoes the last function. Okay, now to do KNN, now keep in mind that the decision, right, is numeric ordinal. So double click on decision, it's numeric ordinal. When we do KNN, which is a lazy learner, the data type of the decision variable, the output variable, the dependent variable, the one that holds the classes 1 and 0, can be numeric ordinal or numeric nominal, and it will affect certain things. All right, so how do we do KNN? Analyze predictive K nearest neighbors. So we are right here. Remember the validation portion was 0.3. The number of neighbors, I'm going to make it 5. What that is, by the way, people come up to me and they ask me, what does this mean? Okay? This is what, I don't mind answering the question, but I want you guys to be independent and to learn to answer questions on your own. Click help. Number of neighbors, K. Maximum number of nearest neighbors to analyze. Models are fit for 1 year up to. So basically, I want you to do KNN using K equal to 1, K equal to 2, K equal to 3, 4, up to 5, and tell me which K is the best. So, that's what this 5 is. Method, you see this method? It has other things here. That's what we're doing. The decision goes into response. The partition, this is the validation, right? You want to call this partition, even though there's something else called partition, which is, right? But, so, that's what this is. You take all the other variables and put them into X factor, all right? We're all set. If you want to remove something, click here and remove it. Click here and remove it. There you go. So I'm going to put it back. All right? And then you click OK. All right. So, now, if you don't get what I'm getting, that's the certain default, you should all be getting the same thing. I don't care about this. So you have the, oops. Oh, no, this is fine. I want to see this. See what it did? It created the misclassification rate, zeros, ones, and plus one zeros, for the training, the validation, and the test. And what I think it does, it looks at the and the smallest misclassification of the validation set, and it looks at the K. And you see confusion metrics for best, this is for the training, for the validation, and for the test. All right? And you can test this on your own. And then, from here, in 14.2, it has other options. So this was 13. Okay, let me go to 14.2 for a second. And what I'm going to do is I'm going to save this locally. Credit approval coded. And I'm going to call this Demetrius, so that's the one I want to use. And I'm going to open jump 14. I could open the other one, but let's just open jump 14. There it is. Okay. Help about, it tells you the version. Help about, where did it go? Let me close this other one. Okay. Anyways, let me do file open and where did I save? Desktop? Where did I save that? Downloads. There you go. All right. So I want to go to downloads. There you go. All right. So now I'm in 14. I think it's different. So analyze, predictive, validation. So we put, oops, we put, don't tell me it doesn't allow me to change things. Get out of here. Make validation call. It froze. All I need is 2 minutes. I'm going back to 13. This is crazy. All right. So analyze, predictive, give me 2 minutes. Make validation, 0.6, 0.3, 0.1. I put in 1, 2, 3, 4, click fixed random. Then I do analyze, predictive, KNN. I put 0.3 here. For K, I put 5. I put decision into Y response. This is what I want to start with next time. Validation into validation. I put these 4 columns into factor. I click OK. This is the output, but I can add other things to the output. I can save the predicted into the table. I can save the prediction formula with a K equals to 2. See now, K equals to 2, for some reason, was the best K in the validation, right? And then I will say, publish the prediction formula. And K equals to 2, that was the best K from the misclassification of the validation set. You look at the best K in the validation. Okay, this is the formula depot. And from here, you, where's my table? This is the table. You see in the table, you have, I wanted to see, K was 5, right? So it gave me the, for each of the 5 nearest, if it was approved or not approved. So for this guy, it was 1, 1, 1, 1, 1. This is the formula that it used to predict. And I'm going to start with this next time. So I'll see you guys Thursday. Okay.